High margins of safety are also incorporated even into the design of the 880's tail antenna. Communications plans include a 1,000-watt transmission system for a range of 1,000 miles at 40,000 feet. A careful study of antenna impedances is made on a test model built high above possible electrical interferences. To duplicate the electrical characteristics of the 880, a model is covered with a fine metal mesh. A satisfactorily strong antenna would place the insulating gap above the highest rudder hinge. Still, the 880 must have an antenna that meets the specification for range and power. A remote control system is installed to eliminate error in readings caused by the proximity of the engineers themselves. When the test system is adjusted, the model is closed, and the engineers go below to the remote control station. Now, a system of pulleys operates the antenna system in the model. An error of even 1 ohm is too much. The readings must be exact. In this way, accurate measurements of limits and ranges are made. These tests paved the way for an antenna which will combine excellent transmission and reception quality with long range and great structural strength in the vertical stabilizer. To make an accurate check on the air conditioning system and temperature control, a completely equipped metal passenger section is delivered to the cold chamber. Here, temperatures can be varied from -100 to +200 degrees Fahrenheit to produce conditions far more extreme than any the 880 will ever encounter. The 880 mock-up room at Convair is the proving ground for experimental design and fixture testing. The consideration given here to passenger comfort is also evident in the 880's pilot compartment. Convenient features ranging in importance from this easily accessible flight kit and data case holder to a secure place to put a cup of coffee have been incorporated. The crew seats are contoured and completely adjustable to any normal operational position. Convair has pioneered in pilot design cockpits, and the 880's front office is designed to reduce pilot fatigue and allow the men who fly it to do their jobs in the easiest, most efficient way possible. Movable armrests make it easy to get in and out. These are the men who will be in these chairs on the maiden flight of the 880. Their combined flight time of over 25,000 hours makes them experts in matters of cockpit comfort and safety. This schematic fuel metering and routing board tells the engineer at a glance the condition of the entire fuel flow system. The position of every fuel valve and pump is clearly visible. His tilted instrument panel puts every control for the electrical, air conditioning, ignition, oil, and flight control systems at his fingertips. The panel is angled so that, if necessary, the pilot can read the instruments from his station. These specially designed fire control handles are within easy reach of both pilots. A pull on the red handle automatically stops fuel flow and ignition to the affected engine. If the trouble persists, the blinker changes to steady red, and the extinguishing switch, safety locks behind the handle, can be operated. 2 sets of levers on this cleanly designed throttle column make it impossible to activate the reverse thrust baffles on the engines without first reducing power. Another safety feature. Special designing has been undertaken to cut the ground handling and out-of-service time costs to an absolute minimum with this aircraft. As an example of the attention given to standard airline maintenance procedures, engine replacement methods for the 880 have been greatly simplified. Engine removal time has been reduced considerably. With the clamshell cowl opened clear out, work can begin on both sides of the engine at once. On engine left, 4 fluid disconnections are quickly made. At the same time, 3 power cable disconnections on engine right and 2 bleed air duct joints. This done, the engine is ready for removal. A specially designed removal cart is wheeled under the engine. Guide rails on the cart are easily lined up with corresponding points on the engine. When the cart has been centered, the cart bed is raised until it is in line with anchor points. The few bolts holding the engine to the frame are removed and rail clamps are tightened down. The engine is then lowered, and the cart is ready for rapid, secure movement to the repair shop. Engine installation is the exact reversal of the removal steps. The tooling program, moving in step with the design and testing programs, will be ready to shape the 880 when every single part and subassembly has been tested to the rigid, fail-safe standards. Minor components are being produced even now. By December 1957, manufacturing on the major component level will have begun. In November of 1958, the first completed production 880 will roll off the assembly line to be test flown the following January. In the meantime, more and more tests are being conducted on increasingly larger test specimens, and never losing sight of the 880's intended purpose, an aircraft of outstanding performance and economy.